In the mid-17th century, Europe was recovering from political upheaval. Science was a chaotic mix of fragmented discoveries and ancient mysticism. Scholars were gathering new data about the natural world, but they lacked a unifying framework to make sense of it all. Isaac Newton was born into this world in 1642. He was a premature, weak baby, born 3 months after his father's death. When Newton was just 2 years old, his mother remarried and moved away, leaving him behind at Woolsthorpe Manor to be raised by his grandparents. That early abandonment cultivated a deeply solitary nature. Growing up on a farm, Newton showed zero aptitude or interest in tending the flocks or managing the land. Instead, he spent his childhood in isolation, obsessively constructing mechanical models, water clocks, and miniature windmills. Growing up without the distractions of a traditional family, Newton became comfortable in a world of his own making. The intense concentration he poured into his childhood mechanical toys established a lifelong habit. He would find more clarity in the predictable behavior of objects than in the complexities of human relationships. Newton was an indifferent student until a schoolyard altercation with a classmate pushed him to retaliate the only way he could, by outperforming him. He applied himself intensely, rose to the top of his class, and earned a spot at Trinity College, Cambridge. But Cambridge was intellectually stagnant, still forcing students to memorize the ancient texts of Aristotle. Newton quickly pushed the curriculum aside. In private, he devoured the modern, radical theories of Descartes, Galileo, and Kepler. Then, in 1665, a severe outbreak of the bubonic plague swept through England. To prevent the spread of the disease, the university shut its doors indefinitely, bringing Newton's formal education to an abrupt halt. With nowhere else to go, the young scholar retreated back to the rural isolation of Woolsthorpe Manor to wait out the quarantine. Far from halting his progress, this pandemic was the catalyst for his genius. Stripped of professors, classes, and social obligations, Newton's mind finally had the completely unstructured, quiet space it needed to break apart conventional scientific dogma. Over the next 2 years, a period historians now call his Years of Wonders, Newton sat alone in Lincolnshire. His solitary obsession poured out into dense, erratic notebooks, filled with manic energy as he rapidly calculated his way through the most complex problems of his day. He started by experimenting with prisms, proving that white light is not a single pure entity, but is actually composed of a full spectrum of distinct color wavelengths. Because refracting telescopes of the era suffered from severe color distortion, Newton used his new understanding of light to design a solution. By replacing the primary lens with a curved mirror, he invented the first practical reflecting telescope. It was also during this quarantine that the famous apple incident occurred. He wasn't struck on the head, but as he sat in his garden, he saw an apple fall from a tree. This simple observation triggered a massive intellectual connection. Newton looked at the descent of the fruit and inferred a specific physical relationship. The Earth was actively drawing the apple toward its center. He then extended this logic past the atmosphere, reasoning that the same force reaching the top of a tree could reach the moon, tethering it in a permanent orbit. For centuries, humans believed that the heavens operated by a completely different set of mystical rules than the objects on Earth. By proving that a falling piece of fruit and a planetary body were governed by the exact same physical force, Newton erased the divide between the Earth and the cosmos. This graph illustrates the mechanical problem Newton faced next. To prove his laws of motion and calculate continuous rates of change along a curve, the existing algebra and geometry of the 17th century simply did not work. To solve his physics problems, Newton had to invent an entirely new branch of mathematics, the method of fluxions, which we now call calculus. Using calculus, he could accurately map and predict the continuous, elliptical paths of planetary bodies as they accelerated and decelerated around a star. Incredibly, Newton kept these world-altering calculations hidden in his desk for nearly 20 years. It wasn't until the astronomer Edmund Halley visited him, asked a question about planetary orbits, and realized what Newton had solved that he was finally convinced to organize his notes. Halley financed the printing himself, and in 1687, Newton published his masterwork, the Principia. The seal of the Royal Society on its title page gave it immediate institutional authority. The Principia provided a comprehensive mathematical framework that unified the laws of motion and universal gravitation. It became the definitive source code for classical physics, providing the tools that scientists would use to measure the universe for centuries. While his public reputation as a mathematician was pristine, Newton's private laboratory was filled with darker, esoteric obsessions. He spent decades quietly engaged in alchemical transmutation, trying to turn base metals into gold and discover the Philosopher's Stone. He was also hiding a dangerous theological conviction. Through exhaustive biblical study, Newton concluded that the doctrine of the Holy Trinity was a fraud. This Arian heresy was strictly illegal. If it had been discovered, he would have been stripped of his fellowship and ruined academically. Keeping these secrets took a toll. Newton routinely forgot to eat or sleep and avoided romantic relationships entirely. The mounting pressure of his extreme isolation and poor diet finally caught up to him, resulting in a severe mental breakdown in 1692. Even when he recovered, his interactions with peers were famously toxic. During what historians call the Golden Age of mudslinging, Newton engaged in vicious, paranoid priority disputes, fighting bitterly with Robert Hooke over the nature of light, and with Gottfried Leibniz over who truly invented calculus. The very traits that allowed Newton to hold complex mathematical variables in his head for months on end were the exact same traits that made him paranoid, easily offended, and socially fractured. Following his mental breakdown, Newton largely abandoned creative scientific research. He pivoted to public life, securing a government position as the Master of the Royal Mint. Operating out of the Tower of London, he applied his ruthless rigor to the English economy. He oversaw a massive recoinage effort and aggressively tracked down and prosecuted counterfeiters, effectively saving the nation's currency. His societal ascent continued. He was elected president of the Royal Society, ruling it with an iron fist, and in 1705, he was knighted by Queen Anne for his service to the state. Isaac Newton died in 1727 at the age of 84. He was buried in Westminster Abbey, making him the first scientist in human history to be honored with a state funeral. The mechanical universe he described reigned unchallenged for over 2 centuries. His formulas provided the direct foundation that later allowed Albert Einstein to theorize relativity and modern engineers to map the trajectories required for spaceflight. Yet, despite an ego that constantly put him at war with his contemporaries, Newton understood exactly how science progresses. Looking back on his life's work, he noted that if he had seen further than others, it was by standing on the shoulders of giants.